This Zoom session is being brought to you by the Fractal Gold Horizon B. All right. Oh, Rapi Sir is coming in. Make a note. Great. Okay. For today, we're going to be doing polynomials. 7, 5, 3, and 5, 4. Polynomials, defining them and adding them. And 5, 4, multiplying polynomials. Now, the term polynomial comes from, well, you see in the word, poly meaning many, and nom for name or term. So it's a sum of terms, many terms, or at least one. A zero-term polynomial would, I suppose, not be there at all. Anyhow, a term is the form of a number times variables to powers. The number is called the coefficient of the term. The powers are called the degree, or degree of the power is called the degree of the term. And the degree of a polynomial is the highest degree of any term in the polynomial. There's some ambiguities if there's more than one variable. Usually we talk about degrees with one variable. So, all right. So you evaluate the polynomial by substitution. Okay, so let's see. First of all, this is 4t squared plus 2t minus 8. It has degree 2. Now, to evaluate at -1, you just plug in a -1 wherever a t is. 4 times -1 squared plus twice -1 minus 8. After a bit of arithmetic, you get -6. P at 0 is 4 times 0 squared plus twice 0 minus 8. You get -8. Generally, the last or constant term is P at 0. Now, add or subtract polynomials. You do is you add like terms. To subtract them, you subtract like terms. Like terms are terms of the same variables to the same powers. So, for example, here we have the polynomial of 3x cubed minus 4x squared plus 2x minus 1. Here and here. Here we have 7x cubed plus 9x squared minus 10x minus 12. Here and here. Here we add those two, and here we subtract those two. All right. 3x cubed plus 7x cubed makes 10x cubed. Minus 4x squared plus 9x squared is 5x squared. 2x plus negative 10x is minus 8x. -1 plus -12 is minus 13. Now here, if we subtract them, we have to subtract them term by term. So 3x cubed minus a 7x cubed, 3 minus 7 makes a -4, minus 4x cubed. Minus 4x squared minus a 9x squared, minus 4 minus 9 is minus 13, so minus 13x squared. 2x minus 10x, 2 minus -10 is 12, therefore 12x. And -1 minus -12 is -1 plus 12 is plus 11. So here's some examples. 3x squared plus 2x plus 1 plus 2x squared minus 7x plus 5. What is it? Well, x squared terms of 3x squared plus 2x squared, that makes a 5x squared. The 2x plus a -7x makes a -5x. A 1 plus a 5 makes a 6. So 5x squared minus 5x plus 6. Okay, we have a 1/5 h to the 6th plus 3/4 h to the 2nd. All that plus 2/3 h to the 6th minus 1/12 h to the 2nd. Here are two h to the 6th terms with coefficients 1/5 and 2/3. So 1/5 plus 2/3 times h to the 6th. You have a 3/4 h squared plus a -1/12 h squared. So that makes 3/4 minus 1/12 times h squared. And then, okay, after a bit of arithmetic or even you can do some cheating on the calculator. The calculator I have here, they have this math button which has a two fraction sub button, so you can use that to do fraction arithmetic, and why not? So therefore 13/15 h to the 6th plus 2/3 h to the 2nd. We have a 9a to the 4th plus 6a to the 4th plus 9a squared plus a. All that plus 2a to the 4th minus 13a squared plus a. Okay, add the a to the 4th. 6 and 2 makes 8. 8a to the 4th. 9 plus -13, it's a -4a squared. A plus a makes 2a. This a looks too much like a 9. I should make a note about changing that. 5.3, page 3a. Now here we have terms with more than one variable, so watch out. 2m squared n squared plus 2mn minus n minus a negative 2m squared n squared minus 2m plus n. What is that? Well, here's an m squared n squared here and here. So those are like terms. So we combine the coefficients. 2 minus a negative 2. 2 minus a negative 2 times m squared n squared. We have a 2m here and a minus a negative 2m here. So 2 minus negative 2 times n. We have a minus n minus another n minus 1 times n. And after some arithmetic, you get 4m squared n squared plus 4m minus 2n. Now here we have three of them.
Excuse me.
Yes, sir.
Excuse me, sir. Why are you separating the coefficient from the variable when you're doing this?
Okay, so, okay. The general way it works is that it's coefficient times variable plus a different coefficient times same variable. So ax plus bx, factor out an x, you get a plus b times x. It's a distribution law. So, I mean, I sense that I haven't answered your question properly. What would you like to know?
Well, I see where you've taken the negative 2, and then the m. You've separated the coefficient from the variable, and then you did your multiplication.
2m minus negative 2m is this, yeah. So 2m minus negative 2m. So I distribute out an m. Therefore, 2 minus negative.
Why didn't you just leave the variable with the coefficient -2 and the m?
So 2m minus negative 2m?
Yeah, why'd you separate it with parentheses?
To make it easier. So yeah.
A little more. Okay, got it. Thank you.
To make it slower and more explicit, I often do things in what I call first gear, just to make sure that everybody's on up to speed. And also, doing it in first gear lowers your chance of making a clerical error. I mean, it is tempting to just skip past steps because you're impatient, but that doesn't actually speed things up because you have to go back and correct things. Okay? And besides, the whole way math works is that it is invented by geniuses, but it's made to be designed to be done by a piece of sand, a chip of sand, and you and I. So here we have them. Now here we have a whole bunch of them. 3 polynomials being added up, and we put them in a column so the x cubes line up, the x squareds line up, the x's line up, and the constants line up. So here we go. 3 minus 2 plus 5, that's a 6x cubed. Minus 2 plus 3 minus 7 works out to a minus 6x squared. 4 plus 3 plus 7 makes a 14x. Minus 3 minus 2 minus 12, add to negative 17, and here we have it. 6x cubed minus 6x squared plus 14x minus 17. Now here we have f of t is negative 6t squared plus 22t plus 4. So what's f at 1? Well, plug in a 1 here and here. Negative 16 times 1 squared plus 22 times 1 plus 4. This comes out a negative 16 plus 22 plus 4, and after a little bit of churning, it's 10. All right, let's see where we're at.